Okay, so like the topic for today is decision trees and random forest. So as the name suggests, so like decision trees are like trees with branchings and nodes and leaves, which helps you to arrive at a decision. And when you combine lot of trees together, lot of trees of different heights, different shape, different color, you get a forest. Similarly, when you combine lot of decision trees together, you get a random forest. Why random? Because in a forest, that all the trees can be of any type, randomly distributed. That's why. So it's just a simple idea to understand the names. So like decision trees is something like which we are studying officially now, but this is something like we all follow naturally. Okay. So say for example, you want to do your recharge. So you want to buy a SIM, or you're buying a SIM. Like you have every all of our phones have two SIMs now. Now you are looking at, okay, which SIM or which service provider is giving me a better deal as compared to like number of SMS I get, the number of data GB per day I'm getting, or the overall pricing, the overall variety. So these are some 4 or 5 parameters which we look at, and then based on that we take a decision. Okay, I'll go for Jio, I'll go for Airtel, right? Or maybe if you're doing a yearly plan, 6 month plan, or a 3 month plan. So maybe for a shorter while Airtel is cheap, but for a longer duration Jio can be cheaper, right? So when you take decisions based on these different features, right? So basically what you are doing, you are actually following the procedure of a decision tree. So right, so decision tree is like you take one factor, you analyze that factor, then you get two or multiple options, then based on that you go down, then you analyze some next factor, then you go further down, then you analyze the third or fourth factor, and finally you arrive at a decision, right? So like you for just for a mental exercise, you can have, okay, so my first category is data. So for a month, for month wise or like daily basis, which one is giving better data, Jio or Airtel? Now you went to Airtel, so your answer is Airtel. Next category is, okay, now what is the price per day or like per month price? So per month you got the answer as Jio. Then the next question is, okay, how many SMSs I am getting? So like the Jio is giving you 100 SMS per day, Airtel is giving you 50. Here also your recharge answer should be, or like your answer should be, your selection should be, decision should be Jio. Then next comes the next category can be how much talk time. Okay, so Jio gives, like Jio to Jio is free, but to on other networks you have like some 1,000 minutes or something. But Airtel, everything is free. So your answer becomes Airtel, right? So for two features your answer is Airtel, for two other features your answer is Airtel. So with this process, at every step you are taking a feature and making a decision based on that, just that particular feature, right? And finally you count, okay, so out of all these 5 features, for 3 times I got Airtel, 2 times I got Jio, so I will go for Airtel. Like this process you follow. Okay, it's very simple. Right. So let's take an example of a day. Like just go back to our childhood when we all want to, on a Sunday morning, we all go. We had a plan to go for a cricket match. The picture is of golf. We can relate to any sport, right? So, but whether we will be going to play or not, or whether there is going to be a match or not, will depend on some of the features, right? So whether the day is going to be sunny or cloudy or windy, right? Whether the temperature is really hot or it is like normal or like it is good to go, whether it is going to be rain or not, right? So on these like several features, based on these different predictors, or you can say features, I will decide, or like these features will decide whether we are going to play or not. So based on these predictors I will have some classification, like whether play or not play, right? Same. So we have some predictors, and based on some predictors we have some classification. This is a simple situation, just for an understanding purposes, right? So how to make a decision tree, right? So we make a decision tree in this way, right? Question: so is it going to rain tomorrow? If it is going to rain tomorrow, yes, then I have certain situation. If it is not going to rain tomorrow, then of course I have other questions. Okay, then like what game should we play, or whether it is going to be cloudy, or like should I carry a water bottle or not, or should I play a leather ball cricket or like normal rubber ball cricket, right? So I have to, the every node has to be a feature, has to be a question. So I'll ask some question, there will be like yes and no's of that. Then once I'm done with this question and go to next level, I'll ask other questions based on this particular condition. Then I'll again go to the next stage, right? So this way I'm making a tree kind of a thing. Okay, because tree, it has branches. So this is the stem, or the like the trunk of the tree. Then I have these two branches, then again these two branches and these two branches, and finally at the end I will have my answers, whether I should play or not, whether I should do the recharge for Airtel or Jio, or maybe Vodafone, right? Or whether I should buy. So same process for any, when you have like multiple options to choose from based on some features, you can always apply decision tree. Which car to buy, which bike to buy, which place to go for a vacation, like whether to book flight ticket, then from which website. Getting my point? Whether I should go for Go IBGO, or I should go Happy Easy Go, or should I go like some other online like Trivago, right? Like that. So we can also apply that to some another position, like to identify whether a customer is likely to buy our computer, right? Suppose we have a computer shop, then of course, like if a student enters, then of course he is going to, so like COVID is starting, everybody is working from home, so like people will be mostly needing computers. So if a student enters, right, so basically if based on their age I can guess, so if a student enters to my shop, he will like surely he has come for a laptop, he will make some inquiry and he has to buy. But if an elderly guy enters like around 50, 60, 75, then he may be just asking for his wife, or maybe some other, he's just randomly asking around, or maybe he is not as sure as a kid, right? So age is one factor. So if he's young, then if he's a student, then if he's not a student, then the choices like probability he'll not buy. If he's a student and he's young, then probably he's buy. If he's middle aged, maybe he's from a working background, IT background, then for sure he has to buy. There is no other classification in that. There is no further rounds of questioning. If he's a senior, then I can, if he has a credit rating, whether he can afford or whether he will buy on EMI. But like for buying EMI for an elderly person, there are different options, because maybe he's not, if he's not earning, how will he pay EMI, whether he can get a loan or not. So all that we have to see, like if it is fair or excellent, right? So with this way of questioning, we can make a flow chart, right? Simple. So like for most of our things where we have to choose or pick between 2-3 options, we have to go through this decision process, decision tree in our background. So we, all of us are doing this. Okay. So now there is something called the purity of the class. Okay. So purity of the class, as in means like if I choose a feature, like is the tomorrow, what is the temperature for tomorrow, what is the outlook for tomorrow, and what is the humidity, like these three factors are the determining factors for a cricket game that we are going to play or not, right? So like if it is going to rain, then we are not we cannot play cricket. We can play football, but cricket is not possible, right? So we can say that if we are looking at the feature whether it is going to rain or not, then it is like pure means like it is going to classify it all the cases completely. If it rains, whatever may be the temperature, whatever may be the humidity, you cannot play. If it does not rains, then you can further like do some questioning, right? So purity of the class means for choosing, if I choose a feature and based on that I perform some classifications, then like whether I'm able to classify it completely or there are some mix and matches. Okay. So that is what
is it like precedence?
Precedence? What do you mean by precedence? I'm not.
I mean priority.
So it's like the concept of priority will come later. Like you are there, but like pure. I'm just talking about purity and impurity of a class. Okay. So based on a feature, if you are able to completely classify in the two classes, then it is a pure class. If you are not able to classify completely, then it is an impure class. Okay. So suppose I have to pick an all-rounder for my team, right? So I have to look at all the features: batting, bowling, fielding of that particular player, right? I cannot just say like he's a proper batsman, right? So he is a proper batsman, but he cannot bowl, he cannot do fielding. So I cannot take him as a all-rounder in my cricket team for my match tomorrow. Okay. So that means for choosing an all-rounder, all the features are going to be impure. Getting, because any one feature is not able to completely classify, okay, this is a complete all-rounder, this is not a complete all-rounder. Any one feature is not able to decide that. We have to look at all the three: batting, bowling, fielding. But when I'm talking about a wicket keeper, then like it is properly set. Like in the real world also we have seen like there are people who are always set for wicket keeping, like these two do wicket keeping, right? So if I look at if I do at wicket keeping, then I can make a complete discrimination between the classes. Okay, this guy for wicket keeping, rest all for others, right? So that's the concept of purity and impurity. And to measure in case of like in terms of in mathematically, we have these two things: entropy and Gini index, right? So there is a mathematical formula which takes into account whatever we just told, right? So basically it will take the proportions of all the features. So if I chose the outlook to be sunny, how many conditions gave me yes we can play tomorrow, how many conditions gave me no we cannot go tomorrow, the proportion of that it will take into account, and it will do some probability multiplication and addition to find the entropy. And same goes with the Gini index. These are the two main mathematical measures of finding the purity of a class, right? So our whole goal is to find like that particular feature we should pick first, which completely gives me yes or no answer, like it which completely classifies my problem, right? So which allows me to have no further rounds of questioning. Okay, so just like for like outlook, temperature, and like whether it will rain or not, out of these three, if I am asking whether it is going to rain tomorrow or not, then my problem is solved, because it rains I need not to check for temperature and humidity. But if I start questioning with, okay, what is the temperature tomorrow? So my friend says, so the Google says it is 30 degrees Celsius or 35 degrees Celsius. Then you can say, okay, the temperature 35. Then next question comes, what is the humidity? Then you will have yes, okay, yes, some answer will be yes, some answer will be no. Then third you will ask, okay, whether it is going to rain or not. So you have to like unnecessarily do some two extra steps. So if you would have just asked whether it is going to rain tomorrow or not, then your whole problem is solved, right? So here the deciding factor will be the rain, or the most priority should be given to the rain feature, which is how to derive that. So like for our particular situation, our particular example, we can say yes, because rain we cannot play cricket, because we have the domain knowledge. We have played cricket and we cannot play cricket on a rainy weather, right? For other cases where we do not have such domain knowledge, we use this entropy and Gini index, which clubs in together all the possibilities, right? So if it rains and if this much is the humidity, how many yeses, how many no's I will get, right? Maybe in the next slide it will become more clear. Okay, so like for formula for entropy is this, like minus the summation of pk log to pk, where k is represents the m number of classes, the target variable pk of a target variable, right? So for our cases, the target variable, the m will be 2, whether we are playing or not playing, right? K will be 2 because there are just two classes, and pk presents the proportion of the samples that belong to the class k. So pk is how many, if I choose the feature weather or the outlook like sunny, cloudy, windy, how many of them are giving me yes we can play, no we cannot play. So pk is the proportion of yeses and nos for both the classes. Okay, then so like this is just a picture to make you visualize what happens. So basically this is my training data, which will have yeses and nos, right? So I have just to know that whether we can play cricket on this Sunday, I collected data for all the past, like for the whole month, last 2 months, and I said, okay, when the weather was windy, when the and the humidity was this much, and it did not rain, we could play cricket. Next row, in the month of January, like in the last month on this Sunday, the weather was cloudy, but the humidity was really high, but still we were able to play. One more day, we have one more row with the data, like this was the weather condition, this was the rain condition, this was the humidity, and we were not able to play. So we have a complete table where I have like in the columns these three features. So what were the values for all the features, and based on the features whether we played or not. Okay, simple normal data in row and columns for this particular problem of our whether we are going to play or not. Based on that, we will make a decision tree like this, and this decision tree will help us to do some predictions. Okay, whether we can play this Sunday or not, whether we can play the next Sunday or not, like whether play or not play. Like here are two classes, and there are some errors also. So this circle and triangle shows me there are some error, and here same thing is here because prediction cannot be always 100%. Right. So this is that formula that is being used to do this division. Right. So let's take a normal actual example. Okay. To how to find the entropy. So this is the table that I was talking about. Right. So these are the different days. So like my friend asked, so some of your friends asked you to, Suchan, can you tell me we can play this Sunday or not? So like you have studied data science, you know, so you like just without guessing and being all optimistic, yes, bro, we can play, whatever happens, we'll play cricket. Instead of doing that, you went for a proper data science approach. You took, okay, so like you based on your knowledge, or maybe some guy told you, okay, these are the features on which playing golf or playing cricket depends or not, or playing any game depends or not. Or like based on your own knowledge, you found this out. right? So like playing cricket depends on whether it is rainy or not, what is the temperature, what should be the humidity, and whether it is windy or not. Based on these things, it depends whether we are playing yes or no, right? So like Outlook can have three values: rainy, overcast, uh, sunny. Temperature have only three values, so all of them are categorical variables, right? There is no particular number. You can also have a number, but in our example, they are all categorical. So they are hot, mild, cold. Humidity can be high, normal, or high, like just two values. And windy is false or true, just two values, right? Whether we are playing or not. So let's talk about, so like what is the probability of playing golf, right? So probability of y.
Vinay,
Yes,
if you
yes.
have a, if you have a, see here we have only taken classical, classified data, that is categorical data. If you have a varying data, how will it split?
Same thing. So you are saying if the columns we are numerical, right? So suppose
Yeah.
suppose instead of temperature saying hot, mild, cold, I'm saying 35 degrees Celsius, 25 degrees Celsius, like that, right? So for that also, like I will have this data also, no? So like for this particular data, we didn't play. For this data we played. So like we will treat them the same way.
But how will it split?
So for that we will split by this way. So whether the temperature is more than 25 or less than 25, right? A branching factor, like that we can do for numeric data, right? So like here in our case, we know like whether playing and not playing almost have a like assuming like they have equal probability, right? So there is no, so they have equal probability means there is nothing is depending on the players. So there is not tomorrow, like some of my friends will come and say, I will not, I don't have, I'm not in the mood of playing. We are ruling out this possibility, right? So we are assuming that the probability of playing or not is equal, 0.5, 0.5, right? So now how to calculate the entropy at the root node? Okay, so my outcome here is what? So my complete outcome is what? Like out of like total, so just consider this much of the history. Out of this, we went to play for like no n n y y y n y n, right? So this is my output. Like there were no 2 times, 4 times no and 4 times yes, right? So based on this, I got the probability of y and probability of no, right? Whether we are playing, whether we are not playing, this is a complete probability. 0.5, 0.5. Out of this, we have found. Then entropy at the root node will become the same formula, summation of pk, summation of pk log pk, right? So summation of py log to y log to py plus both the classes, yes class and the no class. We will take both of them and we will add. And here comes this is how we calculate the entropy. So here the entropy is 1. Similarly, we will do the same for all the other classes. So at the root node, like we had before just starting, this is the case. But if I pick one of them, then the things will change, right? So if I took the Outlook when it was rainy, we played 2 times and did not play 1 time, right? So we will see in the next slide. So like suppose now I'm talking about, I took the predictor Outlook, just one Outlook at one predictor, one feature at a time. So for this feature, we saw that it can be rainy, it can be cloudy, or it can be sunny. So 3 out of 8 cases are rainy, right? 2 out of 8 cases are overcast. 3 out of 8 cases are sunny. So entropy is 9. For this, the entropy is 0.918. For rest of them, the entropy is 0. Right. So for overall entropy using weighted averages, right? So like for the rainy case, it is like 3 by 8. How many times it rained? 3 by 8 times. What is the entropy? How many times it was cloudy? Multiply by the entropy. How many times it was rainy? Multiply by the entropy. Right. So this is the total entropy for Outlook for this particular feature, 0.344. Now, what is the reduction in entropy? Initially, my entropy here was 1, right? Before starting anything. Now, if I choose Outlook, my entropy became 3.44. That means my entropy reduced by 1 minus 0.344. That is this. So basically, this is something information that I gained. Information gain as in if I choose the Outlook, then I got this much of information whether we can play or not, right? You can think of it as in this way. So what is the information that I gained if I chose Outlook to decide as the first round of questioning? If I take, okay, whether it's going to rainy, cloudy, or sunny, based on this, if I do the division, then what is my advantage? What is I'm getting? So that particular number or that particular value which you will look at is this entropy gain. So if I choose Outlook, this is my entropy gain. Now I will repeat the same process for another predictor, maybe temperature. So for temperature, hot, mild, and cold, there are three cases. I'll again calculate all of these things, like out of like how many cases we were able to play, how many cases we were not able to play, right? And I'll find out the entropy, then I will find out the entropy gain. So whichever feature gives me the highest entropy gain, I will split on that feature first. Okay, simple. So just like if I'm talking about rain and am I talking about temperature and humidity, then like based on our discussion, we found out that if I question about rain first, then I'm like every data is completely classified. Like if it is raining, you cannot play. So that means the information gain for rain for that rain feature is the highest, because like if I start questioning this, all of them are solved. If I start asking questions about like whether what is the humidity, what is the temperature, and based on that I want to classify, then the entropy gain is not as high as rainy season or like that rain feature. Okay. So this is like for any problem we can start with any node, with any feature, whether we can start with Outlook, we can start with humidity, we can start with temperature or any other feature, whether right. So we can get different type of trees based on different type of steps of questioning that we follow, based on different type of priority that we do. Okay, so what we are looking for is an optimal tree, right, which takes less time to solve, which gives me which is there is a which solves in the priority of the information gain or entropy or the Gini index, right? So this is like overfitted tree. Overfitted means like it is performing very well in the training data, but in the testing data it will fail measurably, right? For the same application, if you are getting a smaller tree, then of course it is conforming to most of your feature variables, or it is the model is considering all the variability in your data. But this kind of a tree, it is just memorizing everything. Okay, if the temperature is 35, we are not playing. If the rain is there, then we are not playing, right? So it is kind of overfitting. So this is what overfitting tree looks like. This is what a optimal tree looks like. Okay, so we have to continue this exercise, like this exercise. Okay, so once, right, so what we have to start from the start. Before doing any classification, what is the entropy? Then if I take Outlook, what is the entropy gain? Then I take temperature, what is the entropy gain? Then I take humidity, what is the entropy gain? For windy, what is the entropy gain? Then out of all of these four, whichever one has the highest entropy gain, I'll split on them. Once I am split on them, I'll get a new classification or a new table. Then I will find out for these three, what is the classification, what is the entropy gain for the next three. Then I will pick the next highest, right? And based on that I will do division. So we have to like keep repeating. So no predictor satisfy minimum information gain threshold. So we have to keep repeating this exercise when there is no when like all the predictors are giving me like almost same information gain. So like you can ask where to stop. Okay, where to stop at this? So we will stop when like none of the predictors is giving me any significant amount of information gain. Suppose at some point we got information gain for this is 0.1, for this is 0.11, this is 0.09. So all of them are almost equal. So there is no point of splitting further. So that means you can stop the tree. Next condition will be the maximum depth is reached, right? So while defining a tree, I can programmatically define, okay, maximum depth. Depth means one level, second level, third level, fourth level, fifth. So this tree has 5, depth is 5. And for here, like how many levels does it have? Like children, you keep counting the children's, right? So basically this part is called node, and these are the branches. Edges are the branches. They will contain some particular case, yes or no. And this thing are the children. So these two are the children of this one. This is the terminology that we use, right? The third case we will use, there are less than a certain number of examples in the current subtree to prevent overfitting. So these are the three conditions when we can stop. Then like how to stop, like whether to keep calculating entropy or to stop at some point. So one thing is like when no predictor satisfies the minimum information gain threshold. that we set ourselves. Okay, so just like we want to remove the NA values in using pandas, we said okay, if there are more than 90% NA values, you remove the particular column. So that is a threshold that we are setting, right? Some particular barrier. Okay, if the value is more than that, you do something else. Okay, so we are setting up a minimum information gain. If no one said no feature or no predictor is satisfying that value, then we should stop. Or there is a maximum depth is reached. So I have defined, okay, maximum depth is 10. So it will go do this branching till 10 levels. After that, it will stop. Okay, and there are less than a certain number of examples in the current subtree to prevent overfitting. So like if there are, so like after at particular this last point or like this at this current state, there are like very less examples, like just 2 values here or 1 value here, 2 value here, 3 value here, like that, then also we can stop, because there is no point. Because if you're talking about your data is, you started with 10,000 values, and at a particular junction your division, your values or samples became very less, so there is no point of going further, because it is not going adding any extra information. Okay, so so like what is overfitting? So basically, like just like I told in this particular example, it's the same picture. So when overfitting is when your data when your model, instead of generalizing, tries to memorize. Okay, so it is like mugging up or just memorizing every answer word to word for whatever the question is, instead of generalizing. Okay, so if I give 2 input 2 and 1, output is 3. If I give input 4 and 5, output is 9. Right. So instead of developing and developing the understanding or underlying function that there is summation happening, you just memorize. When I enter 2 and 2, your answer is 4. When I enter 1 and 1, your answer should be 2. Right. So you are just memorizing instead of learning what is the underlying pattern. Right. So this is when overfitting happens. So how to check overfitting? We have discussed in that first intro to ML class that any model which is performing very good in testing but very bad in actually very good in training but very bad in testing, that means there is overfitting happening. If the error is increasing after some point, okay, maybe you can go to that site, go to that slide and check. Right. Then
but Vinay,
yes.
But how to find that in the algorithm, Vinay? See, we can't predict that, right?
Of course. So we have to, when we are testing, then we can check. Right. Then when we are testing, so one time we are doing training, then we check with testing, and I see, and when I plot and I see like my error is increasing and my model is giving me higher for every new unseen value, then I need to change some parameter. Then I may have to go back, maybe change the threshold, maybe change the order of priority. Right. We have to change some other parameter, like just like you did in this example, right? Linear regression.
Yeah, I got to know, but how to check that overfitting? How to check it? How to check the overfitting? So see, you told that it can be checked. Yeah.
So you will figure out, okay, how many classification this is doing wrong. So there is that table, no, we discussed that confusion matrix. You will, so once you have trained your data on training set, you will test, and your testing will be, so like on tomorrow, actually I should play, but my model is saying no. And it is happening a lot of times. My model is giving me wrong results on testing data, but it is giving me like very good results on training data. That means the model is memorizing. It is not generalizing. Okay, so this is one way of doing checking. And then pruning is like whatever you do to remove these extra branches, like you change some parameter, you increase the threshold, you change the priority level. That is called pruning. So pruning is, you can pruning actually is that, so if you have seen gardens, like periodically the gardener comes and cuts the extra grasses from a tree, extra leaves, extra branches of a tree to give it a nice shape. That is called pruning. So same thing applies here. So when my model is overfitting, we have to go for pruning, which is like removing some unused or like non-important features from the data set, increasing the threshold, like that. Right. So maybe like this is a new situation, or we are just testing for our data. So like this is my root node. Root means we are just starting, or you can say just note that we are starting with Outlook. My Outlook says rainy, sunny, and overcast. When I am doing rainy, I am getting, every time I'm getting no answer. When I'm doing sunny, I get like 2 times yes, 1 time no. So see, this particular thing is, the class is pure because all of them are of same type. For sunny variable, class is not pure because it is giving me yes, yes, and no, both. There's a mixed class. And overcast is also pure class, right? Because both of them are YY, right? Then because there is a y and no, I have to further ask questions. So whether it is windy, so when it is not windy, I am playing. Whether it is windy, whether if it is windy, I'm not playing, right? So like suppose there is a new situation where like outlook is rainy, temperature is cool, humidity is high, and windy is false. So should you play golf or not? So to predict that, I will use my model which is developed here.
No.
Sujan, you have any question?
No, nothing.
Okay. So this is the new data. This is my testing data. So on this, I will test what result my data is giving me. Okay. This is my new situation which my model has not seen before. All right. So let's take up one more example. Oh, okay. This slide is not coming up nice. So it's like same example for a different game, tennis. So we have like same features here: temperature, outlook, humidity, windy, whether you played or not. Right. So based on that, I want to use this data to predict whether or not he will show up to play or not. An intuitive way to do this is through a decision tree, right? So whether what is the outlook? If it is sunny, rainy, overcast. If it is overcast, then there are 4 values, like there are 4 of the times he came to play. So he came means like we're talking about a friend. If it is sunny and humidity is less than 75, like this is what we were talking about, no? If the number, if the one of the columns is, see here, the humidity column is a numerical column. Rest all the columns are categorical column. So their number, it is not visible. I'm so sorry about this slide. Okay, so like humidity is less than 75, then yes, people are coming to play. If the humidity is more than 75, people are not coming to play 2 number of times, and 1 time they are coming to play. That means this is also not pure. We have to further ask questions here, right? See, it is not completely divided. All the green ones give you a complete division. Whether it is windy, then yeah, if it is windy, nobody will play. Yes, if it is not windy, yes, people will play. This kind of questioning we can do, like, okay, what is the data? Data is like 1.5 GB or like 3 GB or 5 GB, right? So if it is 1.5 GB, what number of SMSs I'm getting? If the number of SMS I'm getting is less than 75, then I'm not buying this plan. If there are more than 75, I'm buying this plan. So like that, you can fit any, like most of the situations on a decision tree, right? So in decision tree, we have nodes. So nodes are the split for the value of a certain attribute. So these rectangles are nodes, right? Where I'm asking a question: what is the outlook? What is the humidity? Whether it is windy or not. These are called nodes. And edges are the outcomes of a split. Okay. So outlook, sunny, overcast, rainy. So these are 3 possible outputs. Right? For humidity, there are 2 possible outputs: whether it is more than 75 or it is less than 75. Right? Then we have a root. Root means where it starts. So this thing is the root here, because it's the start of the tree. The node that performs the first split, right? So outlook here in this particular example is the root. Then leaves are the like final hanging part, last. So these last no, yes are the terminal nodes that predict the outcome. So they're actually nodes, but for understanding, we can call them leaves. So leaves are also nodes, but the terminal nodes. Right. So now let's take an example just to understand the purity of the class. Suppose I have something like they can be yes and no, or like whether I will pay or not. There are 3 features, right? So so that they can be like rainy, yes or no, whether it is windy, yes or no, whether it is sunny, yes or no. Okay. So 1 0 1 0 1 0. Now so let's just look at the data. Can you say, if I start with X, then what can I say? So if X is yes, X is 1 and X is 0. So there are like 2 cases when we are getting a class A. And for this particular case 0, where I'm getting class B. And for this 1, I'm getting class B. But for this Y column, if Y is 1, I am only getting A. If Y is 0, I'm getting B. So like this particular class is classifying the data accurately, right? This particular feature. Right, so splitting on Y gives us a clear separation between the classes. If Y is equal to 1, yes, then class A, no, then class B. If you take other column, if you split on other columns, like if I'm splitting on X, X is 0, X is 1, then 1 time I'm getting B and 2 times I'm getting A, and 1 time B for this particular case. Like there is a mixture here, but in Y there is no mixture. In Z also there is a mixture. For Z is equal to 0, I am getting class A. 1 time I'm getting class A, 1 time I'm getting class B. For Z is equal to 1, same. 1 time I'm getting class A, 1 time I'm getting class B. So basically this Z and X cannot be used to actually divide my classes. Okay. So Y can be the rainy column. If it rains, you cannot play. If it does not rain, you can play. But these can be like, if it is windy, then on some of the days you can play, but some of the days you cannot play. Right. So this is called the purity of the class. Right. So this is the formula for entropy that we have seen, right? And the information gain is the total entropy minus this particular entropy. So this formula is just for your understanding. Maybe like nobody's going to ask you this, but they may ask you some question, some like figurative question. Okay, what measure they use to decide where to split on? That is entropy or Gini index, right? So now let's have a graphical look at, right? So how to do a split. So this is my data, right? So these are like, maybe you can say days. So there are two features: rainy and sorry, this is a temperature, this is humidity, and green ones when we played, red ones when we don't play, right? So this is how we split. So first split perform is this. So if the humidity is 60, less than 60, I have these many classes. If the humidity is more than 60, I have these many classes. So this is the split, how it is performing. Guys, the meeting is
Vinay, you have less than 1 minute.
Yeah. So I think this is the last slide, right? So based on perform like these values, I can perform a classification. So like this is what I have to all discuss in this decision trees. Next is random forest, which we can take up tomorrow, right? Okay, guys, thanks a lot, and happy
Please
Diwali
share the
in
code,
advance.
Vinay.
Yeah, sure. I'll share.
Okay, Vinay.
I'll do
Please,
the implementation
now only
class.
here I'll go.
Okay. Cool. Okay.
Okay, thank you, Vinay.
Thank you.
Yeah, thank you, Vinay. Bye bye, Ajay. Bye bye.
Bye.